During our practicals, again guys, we learned about the following instrument. We had the sensor there. This was called PD or pressure sensor. We had LT or level sensor. We had TT, temperature sensor. Then we learned about FT or flow sensor. So what you need to know here, it's like when you use your cell phone, you guys know that normally before you can make a call, you must have a battery, a SIM card. So also for the sensors, you need to know how to power or to connect each sensor, and also you need to know what is the output from each of them. That's the critical part. If you understand that, there will be no issue or no problem in answering any question about the sensor. For the pressure sensor, one of the things to know is the output signal. Here the output signal, it can be current. We know guys that it's 4 to 20 milliamps. So what you do, always plot this graph. Okay, sorry for that. So this can be 4 to 20 milliamps, and this is your pressure in kilopascal. So 4 will relate to minimum pressure, and 20 is your maximum pressure. Okay, this is linear. So any current in between can give you the related pressure. Simple. The other one is level transmitter. In the lab, we're using capacitor probe. Okay, it had 2 metal. This is insulated. The reason why we add another metal, because the tank was a plastic tank. But if you got a metal tank, there is no need of adding another metal. And there is a capacitance in between. And remember that water is conductive. As the water level increase, there is an output signal which also increases. How this one is powered, I'll come back how you power the circuit. The output from the level sensor, its voltage, it was 0 to 2 millivolts. Therefore, because the controller need 1 to 5 volt, we used to use here an AC bridge to amplify the signal, that to give us an output of 1 to 5 volts. Then for the temperature sensor here, we had 2. We had a thermocouple and an RTD. The output from the thermocouple was voltage. I think you guys saw it was 0 to 3 millivolts. You also still need to use an amplifier or a signal converter to amplify it to 1 to 5 volts. The other one was an RTD. The output from the RTD can be a resistor, but on the multimeter we used to read current is 4 to 20 milliamps. Again, so you can draw the graph. This is your current, 4 to 20 milliamps. On the other side is temperature. The last instrument we used was the flow meter. The flow meter gives you an output of 1 to 5 volt or 4 to 20 milliamps. Again, can put the same graph, 4 to 20 milliamps, and this is your flow. 4 will state the minimum flow, and 20 milliamps will be related to maximum flow. Still linear. How do we wire whole of this instrument or each one? The pressure sensor, before I start, let me go to the thermocouple. The thermocouple hole you need, remember the thermocouple is made of 2 similar metal. This is your hot junction. You need to identify which one is positive, which one is negative. Then if you connect your multimeter across, there is a reading, and you hit up this side. If you hit up there, you hit there, there's a reading is in millivolt. As you can see from the thermocouple, we don't need any external power supply. So in this case, we don't talk about loop power. The loop is not powered. You only get the signal by only hitting the hot junction. This for the thermocouple. Now, let's go back to the pressure sensor. The pressure sensor on the other side is not powered that way. If you want a signal of 4 to 20 milliamp from the pressure sensor, this is your sensor. Okay, it goes plus, minus. You need a 24 volt power supply. You send it there to the sensor. I'll do like this purposely. This is the negative side. But now, because we want to measure the current, this is your multimeter. We're looking for milliamps. So remember the current you measure, you put your instrument in series with the device. The pressure sensor, as you see, there's an external power supply of 24 volts, which powers the sensor, and the output signal comes from the loop, which is going to be 4 to 20 milliamps. That way we talk about loop powered. The loop, this also is a loop, but it's not powered because it's no external power supply. This one becomes a loop because it's powered. Can you see? The loop powered, it's where you use an external power supply, and the measuring device, the one that gives out the feedback, is connected in series with the instrument. That's how you connect your pressure sensor. The temperature sensor, which was the RTD, you had your RTD there, no polarity. It was connected to a transmitter. Then a transmitter also was powered with 24 volt. Again, that one goes there, I did purposely. Again here, see that the multimeter is not connected on the side of the instrument. It's always connected on the power side. Again, because we're looking for 4 to 20 milliamps, we have to put our multimeter there, and we'll read a value in milliamps, which can be 4 to 20 milliamps. This setup also is called loop powered. I'm sure you can see the difference. That all you're looking for is a signal. If it's not 1 to 5 volts, it's 4 to 20 milliamps. It's the most important signal you guys need to remember for instrumentation. That's what you'll be dealing in practical. Here you had your, on the transmitter, is a transmitter, you got your 0 and the span. So the 0, remember, is for low range calibration. You must state that it's 4 milliamps, and the span is for the high range calibration, which must be 20 milliamps. It's not 5 volt, it's milliamps, so you must specify that one. Okay, thank you. I'm sure this can be helpful to you. Good luck, everybody. Bye-bye.